Welcome to Computer Science IGCSE, and we are on chapter number 1, data representation. And we have started the topic of data compression. We have two types of compression tools, lossy and lossless.
Look.
We also done MP3 and MP4. Have we
Yeah.
done? Yes.
Yes.
After MP3 and MP4, there is another type of compression tool called Jpeg. Have we discussed about Jpeg?
No.
Yes. What is Jpeg? Let's read today. Whatever the pictures in your camera gallery, do you know that all pictures are in which format? They all are in, yes, Jpeg. Okay, whatever the pictures you download from internet, they all are in a format of?
Jpeg.
Yes. What is the full form of Jpeg? Any idea?
No.
Joint. Acha, you of course you download thousands of wallpapers, pictures, hundreds of pictures in your phone. You never think what is the full form of Jpeg? Joint photographic, yes, expert group. This is a full form of Jpeg, right?
Yeah.
Tell me the full form of Jpeg now.
Joint Photographic Expert Group.
Yeah, so whatever the pictures in your cell phone, in your laptop, are always in a JPEG format. So now let's study what is JPEG. When a camera takes a photograph, it produces a raw bitmap file, which can be very large in size. Yes, the pictures are extremely big. So these files are temporary in nature. JPEG is a lossy file compression algorithm used for that bitmap images. So whatever the bitmap images are there, which are big in size, so the JPEG is there to reduce their sizes. And then they are able to store in our computer memory. So which type of JPEG is a compression tool? Lossy or lossless?
Lossy.
What is lossy?
It means like some data is lost during the compression.
Very good. And the compression, the compress, they're going to be done with the picture or with the sound file. Are they noticeable?
Yes.
They are not so noticeable. Yeah, they are not so noticeable, right? I think I have shown you a picture, two pictures. So I told you that what is the difference between that two pictures, remember? In the last lesson?
Yeah.
Yes.
Yeah.
Okay, so JPEG deals with the lossy compression tool. Okay, as with the MP3, once the image is subjected to the JPEG compression, a new file is formed and the original file can no longer be constructed. This is the problem. Like if you are going to compress your picture with the JPEG format, your old picture will be deleted forever. And the new compressed JPEG picture will be there. Is that okay?
Yeah.
So that is about lossy. Remember? Okay.
Yeah.
So the JPEG file reduction process is based on the two key concepts. So there are two concepts. The two key concepts are, number one, human eye don't detect differences in color shades. We have discussed this thing in the last lesson. I show you two pictures. With the help of that two pictures, you're able to recognize a difference. But if I'm going to show you one picture at a time, believe me, you cannot detect the difference. So they detect differences in image brightness. So the eye is less sensitive to the color variations than it is to variate brightness. So yes, you are able to recognize that, sir, this image is brighter than the previous one. Yes, you can easily detect it. But sometimes our eyes are not able to detect the color shades, the minor difference. So the first key principle is human eye don't affect the differences in color shade. Number two, by separating the pixel color from brightness, images can be split up into 8 into 8 pixel blocks, for example, which then allows certain information to be discarded from the image without causing any real noticeable deterioration. Okay, what happened? This is your picture. Let's suppose this is our picture. It's a square. You are going to compress your file, look, in this way. And this whole area will be deleted. Only this area will be there. So this area will be there in a form of 8 by 8 pixel size. And rest of the area will be deleted. So this is how the JPEG works. Is it okay?
Yeah.
Please write down the JPEG points. You have only 3 minutes for it. Form of RLE. Run land.
Encoding.
Yes. Do you know about RLE? Any point? Anything you know about it?
No.
Okay. RLE basically used for lossless compression. So this is not example of lossy. I teach you JPEG, MP3, and MP4 for the lossy. But for lossless, we have RLE, run length encoding. So it is a form of a lossless. It means it is reversible. It means you will get your master file, right? So it means your parent file and your son file, both will be saved. Parent file means original file. Son file means a file which is compressed. Are you getting it?
Yeah.
Okay. So the run length encoding can be applied on text data as well as on images. So I'm going to start with the text data. It's very easy. Let's suppose you have some characters which are repeated for a number of times. Like A. How many times A is repeated?
5.
Very good. How many times a B is repeated?
4.
C.
2.
D.
5.
5. You need to write down the number of times. Like you see 5, you see 4, 2, and 5. But what is that thing, 97? What is that thing? 97 basically is an ASCII code. Yes. ASCII code for A in a denary is 97. Can you tell me the ASCII code for B?
98.
Can you tell me what is the ASCII code for C?
99.
Can you tell me the ASCII code for D?
100.
Can you tell me the ASCII code for I? Yes.
105.
Yes, very good. So you are going to calculate it. So we are talking about, I think, denary. So this is about denary. If I'm talking about hexa, the values are changed. Okay. So you need to write down the number of times along with the ASCII code. Okay. Now, how do we come to know that our data is compressed? Okay. Tell me the total number of characters. 5 plus 4 plus 2 and plus 5. It will be 16 bytes. Isn't it? How many bytes are there?
16.
Calculated. You're not sure, I think.
Now it's 16.
Okay. After compressing it, how many bytes are there? Look, this one considered as 1 byte. This one is 2 byte. This one is 3. This one is 4. This one is 5. This one is 6. This one is 7. And the last one is considered as 8. So how many bytes are there now?
8.
So what do you think? Have we compressed our data?
Yes.
How much percent is this?
50.
Very good. So look, RLE works for the 50% compression. So it reduces a huge size of your text data. Is it okay?
Yeah.
That's great. Okay, now consider this example. So you have A, B, C, D, again C, again D, again C, again D, and E. Can you tell me the total bytes, please?
$32.
32 bytes. That's good. 32 bytes. I'm just writing B. Is that okay?
Yeah.
Okay, after compressing the data, what will be the answer?
18.
18 bytes. So again, a huge compression will be there. So the original size is 32. The compressed size is 18 bytes. So look, this is how we are going to compress and make our data compressed. So take out your notebook. First, you need to write down about RLE. There are several points. You need to pick any 3 points from RLE first. Like you pick this one. You need to pick this one, 2 points. And then you need to write the examples. Remember the ASCII, okay?
Okay.
Start work. So I told you about the compression and we have discussed the RLE as RLE for text. Now I'm going to teach you RLE for the images. So let's see how it works. So first I'm going to teach you RLE for the black and white image, okay? So in black and white, you see this grid. Can you count the number of rows and columns for this grid? 1, 2, 3, 4, 5, 6, 7, 8. 8 columns, and of course, there are 8 rows.
8.
So what is the size of this grid? 8 into 8.
8.
64 bytes.
16.
Very good answer. How much bytes?
64
bytes. This is a total size. Now we are going to use a compression tool in order to see how much we compress this, okay? Now, yeah. Figure 1.12 shows the letter F in a grid where each square requires 1 byte of this grid. So I told you 1 byte. So 8 into 8 means 64 bytes. A white square has a value of 1 and a black square has a value of 0. You have to understand this. 1 is going to be represented for a white color.
White.
And black is going to be represented for black.
0.
This one, look. First row is whole 1. Why it is whole as 1?
Because it's white. Oh.
White, very good. Tell me about the second row, this one. So this one is a 1. Yeah. And black one considered as?
0.
Look, I'm writing it for you for better understanding. And that's it. Look, this is how I write this. In the third row again, you need to make 1, then 0, and then 1. Is it okay?
Yeah.
So for the rest of the image, you need to write down the binary pattern like that. After completing all the rows, you are going to write down the whole thing in a form of white and black. So tell me the first row, how many bits are there in first row?
8.
8. Is it black or white?
White.
So you need to write 8W. In the row number 2, how many whites are there?
6.
White.
Oh, whites 2.
2 white. And how many blacks are there?
6.
Achha, it is possible that you swap, like first you write 2W, then you write 6B. It's okay. It's not considered as wrong, okay? Now tell me the row number 3. How many black you have?
1.
How many white you have?
7.
Tell me row number 4.
1 black and 7 whites.
Tell me row number 5.
5 blacks and 3 whites.
Tell me row number 6.
1 black and 7 white.
Tell me row number 7.
1 black and 7 white.
And row number 8, 1 black and 6 white.
7.
Now
6
you're
white.
going to replace W with a 1 and B with a 0. So with the first one, 8W, what we have to write?
8 1.
8 1. What about row number 2?
6 0 2
And 2 1. What about row number 3?
1 0 7 1.
1 B. B represents 0. So I write 1 0. And 7W. 1 is going to be replaced by W. So 7 1. And so on. Now, as we calculated in the start, how many total bytes we have in the grid?
64.
And now calculate all these bytes and tell me how many bytes are there? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, right? And every set is of how many numbers?
2.
2 numbers. So 15 twos are
30.
30 bytes. How many bytes?
30.
30 bytes. We have to say bytes as well. 30 bytes. So the total size is 64. And after RLE, we get 30 bytes. So look how we are going to use the compression. Any confusion?
No.
Take out your notebook, draw this diagram in a rough way, and write down everything.
Okay.
Black and white image. Now we have to work on the colored image. Colored image is a bit different. You see, we have 3 colors, not 3, 4 colors. Black, white, green, and red. And you know, every color have an RGB frequency. Do you know about everything in the world is being made by 3 primary colors? What are they?
Red, green, blue.
What about secondary colors? C, M, Y, K. These are secondary colors. Is it okay?
Yeah.
So everything is in our universe is made by RGB, right? Red, green, and blue. So a bit frequency of all these colors are present in every color. So in black, we don't have red, green, and blue, so 0, 0, 0. In white, we have 255, 255, and 255. In green, we have 0, 255, 0. In red, we have 255, 0, and 0. This is a frequency of RGB colors, right? So it is provided in exams. Now, tell me the total grid size. 8
8
into 8. Very good. So what is the size?
64 bytes.
Okay. But you say, sir, we are dealing with the black and white with the same thing. So what is the difference? In color, you're going to multiply 64 by 3. Why? Because we are having the 3 primary colors, RGB. So we are going to multiply it by 3. What is the answer? 64 into 3. Yeah.
192.
192. So what is the size of this color image?
192 bytes.
Very good. 192 bytes. So we are going to compress it and check how much bytes it consumed after compression. So again, the same thing. This one is black. This one is black. Come on, tell me. This one is?
Green.
And the last one is?
Black.
So this is our first row. You need to write down the first row with the help of these codes. So tell me, what is the first code?
0, 0, 0.
How many times are there?
2.
So you need to write 2, 0, 0, 0. Okay. How many green you have?
4.
And what is the frequency of green color?
0, 255, 0.
What is the next?
Black.
How many times?
2 times.
And what's the frequency?
0, 0, 0.
That's it. So this is for first row. Then row number 2. Again, the same thing I told you. If the order is not like that, so no need to worry. Just like this, they have written 6. It means they have written white first. How many times white is there? 6 times. What is the
6
frequency?
times. 255, 255, 255.
And then how many times you have black? In the first and in the second. So you can count it as 2. So you can take 2. Because in the right hand, we have first black, and on the left hand, we have first black, right?
Yeah.
So you need to complete this right now by your own. And don't see this sequence because there are a lot of errors in this sequence. You can see I corrected 2 in just one row. So you need to do this pattern by your own and get back to me once you're done.
Okay.
You need to focus on the colors in the picture, this grid.
Okay.
I'm waiting. So how many bytes did you get after compression? Did you count?
No, I didn't count it. I forgot.
Important. You can't forget it. You need to count it. Count and let me know.
Okay.
Be careful. It's it's kind of confusing. Like, if you're going to count them, let me make it work easy. It will be 92 bytes. How many bytes?
92.
92. So you can do it in your homework because it takes a lot of time to count and it's very difficult. So the original, what is the original size of the image?
192 bytes.
And now what is the size after compression?
92.
So it means that we compress the files around how much percent? 52%.
52%.
Yes. So in this way, we have finished our chapter number 1 today. And I'm going to give you some questions.
Okay.
Right on your WhatsApp, I'm going to send you the questions right now. Okay, and for this moment, I'm going to share you some further questions. Okay. Chapter number 1. Okay, here we go. So let's see the mind map of our whole chapter that we have done the conversions first. After conversions, we have done the sound, images, right? And then we have done the compression tool. So 3 topics are finished in this way, right?
Yeah.
Okay. Now a revision task. I'm going to give you some revision questions. Revision task. Question number 1. Here we go. Okay, so this question is: the editor of the movie is finalizing the music score. He will send the final version of this score to the movie